First step is to make a couple options with this. We've got a 4-inch square box, and I might want to replace this now with a 2 1/8 inch deep box. But instead of adding multiple copies of assemblies or weeding through so many of assemblies, the power of IntelliBid is the ability to create what we call an assembly group. You've probably seen those in a number of existing Conus assemblies, but let me demonstrate here. I'm just going to go down to this EMT line. I'll show you what this means in a moment. And I'm going to go back to Explore for a moment to go to the device box section. Grab the 4-inch square and scroll down to the, till I find the 2 1/8 inch deep box that I want. I'm going to again use the combo no bracket style. And then in this case, instead of appending it as a component to the assembly, I'm going to insert it. And because I'm on this line, the insert always inserts above the line I'm on as I'm on selection. Now I've just added a second device box to my assembly. Now I don't want obviously both, but the concept here is to highlight both of these and then right click and create your own assembly group. And I'm going to call this my group 4-inch square boxes. 1 square box option. Call it anything you want. And what the program's done is group these together. This is actually group 736. You can actually use this to your advantage in the job spec. If the entire job is going to be 2 1/8 inch, you can set it to be that and not have to make your choice. But instead of having 2 assemblies now, I could actually get rid of this one and now just stick with the 15-amp duplex receptacle. Now, one extra option here to add to the mix is we've done everything by quantity. Now we're going to do everything by length. Now, the length formula in the IntelliBid database in version 6 and in version 7 is F4, but the new database has got every component as a single entity, and I'm going to show you here in a moment. I'm going to go into the formula variable and actually create a formula right now on the fly just to show you. I'm going to create one that's actually still going to prompt on length, similar to the formula here F4, but I'm going to duplicate this, but I'm also going to now multiply it by the quantity, which is the new method in version 7, but I'm now going to use the ampersand because I want to use it in variable memory because I'm already going to be prompting for quantity. And I'm just going to do L ampersand times Q pound, and I've got a new formula F7 that I want to use here. Now I'm going to close that formula maintenance down and go back to the duplex receptacle here, and I'm going to introduce wherever there's an item in this assembly that's dependent on length, I'm going to change the formula to F7. Select F7, hit OK, and couplings, that's dependent on length. So I'm going to change that to F7. The connectors, they're going to be still dependent on the quantity. I'm going to leave those. Straps, they'll be dependent on length. The wire is dependent on length. So anything dependent on length, I'm going to make F7. Now what I do is I come down and look at the F7. For every one receptacle counted, gives me in the multiplier 1 foot of wire, and in this case, or 1 foot of conduit. So I'm going to be prompted on length and give me 1 foot of conduit. Prompt on length gives me, in couplings, I'm going to use 1 coupling for every 10 feet. So it's how many and how often, and that's a ratio of 1 to 10 So I put a multiplier in terms of a decimal. A ratio of 1 to 10 is 0.1. The connectors, I don't worry about that. That's already been set based on my quantity. My straps, now I want 2 straps for every 10 feet. And that is the ratio is 0.2. My wire, I'm going to use phase and neutral. I want 2 wires for every length counted, but I'm going to actually add 10% wastage to it. So I'm going to make it 2.2 wires added for every length that I'm prompted for in my entry. And then my ground wire is going to be 1.1, giving myself 10% wastage on my ground. Now, this is a little different of an assembly, and that's why I've renamed it as variable EMT, because now this is going to allow me to take off one duplex receptacle, choose the style of receptacle or box itself. In fact, if I wanted to, I can even come in here now and grab the duplex receptacle as a 15 amp. Actually, I'm going to grab the 20 amp that I meant to grab. And I'm going to insert that just above this duplex here. I'm going to highlight these two, create another assembly group called my group. My group spec grade duplex receptacle, just something. So now I have an option to choose. In this case, I'm going to remove it and call it 15 amp slash 20 amp duplex receptacle. And in fact, I can get rid of all these two assemblies right here by deleting them. All the assemblies that I just created, instead of having the 4 or 5 that I've created, I've got them all in one assembly with the option to choose the length on the conduit and so forth. So let's go back to the takeoff and test our assembly. You're always encouraged to test every assembly. I'm just going to go to the device section here to have a blank area. Wiring or device flush, my custom device catalog. Here's a standard duplex receptacle. And here's my one assembly. Select this. I have some options. Do I want to use a 15 amp or a 20 amp device, or in the style or the depth of the box? So I'm going to grab a 20 amp with a 2 1/8 inch deep box. Select takeoff. I'm going to grab 10 of these, and I'm going to use 15 feet of conduit. And when I close this down, open or resize the grid to take a look, you can see now here's the 20 amp duplex with the 2 1/8 inch deep box and the variable length on conduit and so forth, and one assembly. And simple, without using too many complex formulas. We added one formula in there in the libraries, and are able to make a number of assemblies. And just consider that this is the box, the conduit, and the straps. You could even replace the wire with cable, put some other device on the end of this, and make a number of assemblies from this one created assembly.